So, hi everyone, welcome back to another video. And today we're going to be starting with Cambridge O Levels Chemistry Paper 2 Theory, October November 2023, Paper 21. Okay, so this is going to be an O level paper, so it's going to be a bit longer. So, let's start by reading the first question, which says choose from the list of compounds to answer these questions. Okay, we have calcium oxide, we have carbon dioxide, calcium oxide, carbon dioxide, carbon monoxide, then we have lead chloride, PbCl2. Then we have propanol. Propan is gonna be C3H7OH. This is propanol. Then we have sodium nitrate, which is gonna be NaNO3. Then we have sodium sulfate, which is gonna be Na2SO4. Then we have sulfur dioxide, which is SO2, and then we have water, which is H2O. Okay, this step is not important that you have to write the chemical formula of everything, but I've just written in case it helps. That's going to be good. Each compound may be used once, more than once, or not at all. Identify the compound that is a toxic gas produced by the incomplete combustion of carbon containing compounds. Always remember, whenever we do incomplete combustion, we always produce carbon monoxide, and when we do complete combustion, we produce carbon dioxide and water. In incomplete combustion, we can either produce carbon monoxide or we produce simple carbon. So this is going to be carbon monoxide. Okay, next is turns anhydrous copper sulfate blue. Do you guys remember turning anhydrous copper sulfate blue and turning anhydrous cobalt chloride from blue to pink was the property of water? Do you remember the chemical test for water? That you add a few drops of water on anhydrous cobalt chloride and it turns from white to blue. So that's gonna be water. Water turns it from white to blue. Okay, leads to deoxygenation of water in reverse. Okay. Now the thing is, you should know that deoxygenation is caused by fertilizers. How is deoxygenation caused by fertilizers? Because these fertilizers, they contain nitrates NO3 and phosphates PO4 2 negative and nitrates 1 negative. Now these are the ions, nitrates and phosphates. When these ions, which are in fertilizers, go to river waters, basically they cause excessive growth of a substance called algae in water. And algae, when algae dies, okay, now this is your water body, these nitrates and phosphates cause the excessive growth of algae. Now when this algae dies, bacteria decomposes it. Okay, when this algae dies, bacteria decomposes it, and basically to decompose it, the bacteria uses up all the oxygen. Okay, to decompose it, bacteria use up all the oxygen of the water, leading to the deoxygenation of water. Other creatures in water don't get enough oxygen, so it's going to be a nitrate or a phosphate, because nitrates and phosphates cause the deoxygenation. So it can be sodium nitrate. We have sodium sulfate. Let's read other options. So either no, it's not sulfate. Sorry, it's not sulfates. It's only it's nitrates and phosphates. It's going to be sodium nitrate. Okay, sodium nitrate. Okay, let's move on. In aqueous solution gives a white precipitate on addition of acidified aqueous barium chloride. Barium chloride, when you add in it, it gives a white precipitate. Can you guys guess that which salt of barium is insoluble? Barium chloride is soluble. All chlorides are soluble except lead and silver. Barium chloride is 100% soluble. The barium salt that is not soluble is our barium sulfate. Barium sulfate is an insoluble salt. So in aqueous solution, the solution which is going to give a white precipitate with barium chloride is going to be a sulfate salt, and that's going to be the precipitate. This white precipitate is going to be barium, BaSO4, barium sulfate. So it is going to be sodium sulfate. Okay, let's move on. Contains an anion with a charge of -1. Okay, let's find out the anion with a charge of -1. Okay, over here the anion is oxygen, a charge of 2 negative. Oxygen. Okay, now PbCl2. What do you think about it? Look, Pb is 2 plus and Cl is 1 negative, and we use 2Cl to balance out 2 plus charge, ठीक है. Pb was 2 plus and Cl was 1 negative, and we use 2Cl to balance out the charge of 2 plus, so it becomes 2 negative for 2Cl. So for 1Cl it's going to be 1 negative, ठीक है. So the anion with the negative 1 charge the compound contains is going to be lead chloride. Okay, so now let's move on to the next question, which says, this question is about metals. Potassium is an element in group 1 of the periodic table. Copper is a transition element. Okay, now they've told us that potassium belongs to group 1 and copper belongs to transition elements. State two physical properties of potassium that are different from those of copper. Okay, now basically what they're asking for is the differences between, potassium is in group 1 and copper is a transition element. So they're asking for the differences between group 1 and transition elements. Not specifically between potassium and copper, it's about group 1 and transition element. So we know that group 1 metals are soft while transition metals are hard. I'm gonna write that group 1 metals have low densities and two physical properties of potassium that are different from the potassium is soft. Okay, potassium is soft, and you can also write instead of group 1 over here as well, you can write that potassium metal have low density. Okay, not instead of densities, you can write that potassium is low density, and then you can write that potassium is soft while copper is hard because transition elements are hard, whereas group 1 metals are soft, transition metals have low density, group 1 has high density. Complete the diagram in figure 2.1 to show the electronic configuration of a potassium ion. Include the charge on the ion. Okay, we're given with the shells, and now we gotta check how many electrons potassium has from the periodic table. So we exactly know the number of electrons of potassium. So over here potassium has 19 electrons, and as we know that potassium has a charge of +1 because it is in group 1. +1 means that it basically lost 1 electron. So it had 19 in the periodic table. Now it lost 1 electron because we have a charge of 1 positive. So now it will have 18. So let's draw 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Okay, done. Table 2.1 shows the observations when 4 different metals react with cold water. ठीक है. Put the 4 metals in order of their reactivity. Put the least reactive metal first, least reactive first, most reactive. Achha, what they're basically asking for is that from this, in cerium bubbles form slowly, in potassium bubbles form rapidly, in uranium bubbles form very slowly. ठीक है. अब slowly ज़्यादा slow है या very slowly? Obviously very slowly, तो very slowly is going to be the least reactive. No bubble seen. अब now no bubble seen is more slowly than very slowly, so it's going to be the least reactive is going to be vanadium. Why? सबसे पहले it's going to be no bubble seen, then it's going to be very slowly, after that slowly and rapidly. It's simple, the game of words. You gotta look at this list of words. ठीक है. This slowly, this rapidly and very slowly, it all is going to tell you that. Okay, first we have no bubbles form. That's obviously going to be the least reactive because it does not react. That's why no bubbles form. After that, it's going to be very slowly, which is uranium. After that, it is going to be slowly, which is cerium. After that, it's going to be rapidly, which is potassium. Okay, done with it. Let's move on. Reduce the number of protons and neutrons in the copper atom shown. The number of protons. Okay, they're down over here. This is the proton number, so it's going to be 29. And your number is neutron is basically at the top you have your mass number. To get the number of protons and neutrons. So in order to get the neutron, you subtract the proton number from it. So that's going to give you 6 and 36. Okay. In the presence of oxygen, copper reacts with sulfuric acid H2SO4 to form copper sulfate and water. Okay. We're gonna write that in the presence of oxygen, copper reacts with sulfuric acid. So, copper plus sulfuric acid mind we have oxygen as well. We got to figure it out as well. First, let's form the products. Copper, H2, sulfuric acid was H2SO4. Then we are forming copper sulfate and water. Water is gonna be H2. Acha, now why they've written in the presence of oxygen? What do you guys think? Why they've written that in the presence of oxygen? Why not in the presence of oxygen copper cannot react? Because they can. Let me tell you guys. What they're telling us is that it is not copper reacting. First, I wrote the equation for you guys. Basically, copper forms an oxide of copper oxide, okay? And then that oxide reacts. Okay, I'll tell you guys one thing. The metals that are lower in the reactivity series than hydrogen cannot react with acids. Okay? Hydrogen is here, copper is below. So copper cannot displace hydrogen from the acid. So copper cannot react. But copper oxide can. So basically what they mean over here was copper oxide. Okay? And that is going to be your equation. And let's see if it is balanced. It is balanced. Okay? You got to form an equation with copper oxide, not with copper. Okay, copper can be used as catalyst. State how catalyst increases the rate of a chemical reaction, obviously by lowering the activation energy. You can write E, a symbol for activation energy, but it is better if you write the word activation energy, by providing an alternative pathway for the reaction to proceed. You can also write that by providing an alternative pathway for reaction to proceed. Okay, let's move on. Name a catalyst used in the contact process. Please, everyone, learn the catalyst for the Haber process as well as the contact process. For Haber process, we use iron, and for contact process, we use vanadium oxide. Okay, it's vanadium 5 oxide. Okay, give 2 reasons why copper is used in electrical wiring. Okay, it is clearly stated on the syllabus that you got to learn the reasons for the use of aluminum and the use of copper. Okay, now we're using copper in wiring. Okay, we're using copper in wiring. To make wires, you need a material that can conduct electricity, because the purpose of the wire is to conduct electricity. So the first reason is going to be good electrical conductivity. Good electrical conductivity. And the second reason is going to be, I'm going to tell you one thing. Okay, in order to make wires, you got to mold your metal into the shape of a wire. Okay? For example, if you take iodine or oxygen or any non-metal and you try to shape it in the form of a wire, it is going to break apart. But the property of copper is that copper is ductile. It can easily be shaped into wire, so it's going to be ductile and good conductor. A student investigates the reaction of small pieces of zinc with dilute hydrochloric acid at 25 degrees Celsius. ठीक है, acid is in excess. Complete the equation. देखें, zinc जो है, it's a metal, so it's going to be a solid. We're going to write S. Hydrochloric acid is, देखें, hydrochloric acid basically is, first it's hydrogen chloride gas, and then you dissolve it in water, so it forms hydrogen ions and chloride ions. So for that we write aqueous. For any soluble substance we write aqueous. Zinc chloride is soluble, that is why they've written aqueous. H2 is a gas, so we're going to write gas. Shows the volume of hydrogen released as the reaction proceeds. Reduce the time taken from the beginning of the experiment to collect 39 cm cube of hydrogen. Okay, we have to reduce the time from the beginning to 39 cm cube. Okay, that is 35, 36, 37, 38, 39. I'm going to draw a straight line on 39, and that is the time. That is 150 seconds. Okay? Okay, the student repeats the experiment using dilute hydrochloric acid with a higher concentration. Higher concentration means faster rate. I'll explain you the concept of concentration like this. You have 2 beakers. Beaker 1, beaker 1. Over here you have 3 particles. 1, 2 and 3. Over here you have these many particles. Now tell me in which beaker, both beaker were of the same volume, I didn't change the volume. But in which beaker, beaker 1 or beaker 2, do you think the reaction is going to be faster? Obviously in beaker 2, because there are more reactant particles in the same volume. The particles are more, the concentration is greater, the spaces between them is less, they collide more frequent. That is why the concentration, when you increase, the rate becomes faster. All of the conditions stay the same. Draw a line on the grid in figure 3.1. Acha, I'll tell you one thing. 3.1, to show the volume of hydrogen changes when dilute hydrochloric acid with higher concentration is used. Acha, first we'll check what was in excess. Acha, the dilute hydrochloric acid in excess. Dekhe, I'm going to write one line over here that the reactant in excess cannot determine the amount of product formed. Cannot determine the amount of product formed. Okay? Any reactant that you take in excess, that cannot determine the amount of product formed. The amount of product formed is determined by the limiting reactant. So we're taking hydrochloric acid in excess. So this means that the hydrogen is basically is the product. So hydrochloric acid cannot determine the amount of hydrogen. Okay? Only zinc can. Why? Because zinc is the limiting reactant. And hydrochloric acid in excess. The substance in excess cannot determine the amount of reactant you form. So basically, even if we change this concentration, though the rate is going to be faster, but the amount of H2 formed will not increase or decrease. The amount of H2 can only increase if we increase the concentration of the limiting reactant. Okay? Even if you increase the concentration of hydrochloric acid to a maximum, you cannot increase the yield because this is excess. Excess cannot determine the yield. So the rate is going to be faster. So but the product line will be same. So faster rate means that I'm gonna start my graph something like this, and I'm gonna finish on this line. The finish of this line. So I'm also gonna finish a little before them, because this shows that my reaction finished before this one. This means that my reaction finished before this reaction. This curve is steeper. That means more faster reaction, because in this I had a greater concentration of HCl. But my product, please don't change the amount of hydrogen, because the amount of hydrogen is not determined by the limiting reactant. Draw a line on the figure to show the volume of hydrogen changes. Done, the student repeats the experiment at 30 degrees Celsius. First, the student did the experiment at 25 degrees Celsius, and now it is done at 30 degrees Celsius. All of the conditions stayed the same. Describe and explain using collision theory how the rate of the reaction at 30 degrees Celsius is temperature. At 30 degrees Celsius, rate will be faster as particles have greater kinetic energy. So they move faster, and hence collide with each other more frequently. Higher temperature means that more particles have energy equal to or greater than the activation energy. increasing frequency of effective collisions. Okay, a sample of hydrogen is put into a gas range. Okay, the end of the gas range is then blocked so that no gas can escape. Okay, basically you have this syringe and you put your hydrogen gas in it and you block the syringe so that no gas can escape. Explain using kinetic particle theory why decreasing the pressure in the gas range increases the volume of gas when temperature is the same. देखिए, decreasing the pressure in the gas increases the volume. The particles, देखें वॉल्यूम कैसे इंक्रीज होता है. देखें आपके पास दो ट्यूब्स हैं. You have two tubes. In this you have a greater pressure. ठीक है, more pressure means particles are close together each other. ठीक है. Now you lift this piston. ठीक है, you lift up this piston and now the pressure is less, so the same. देखें we had 1 2 3 4 5 particles. The same 1 2 3 5 particles now have more spaces between them. They had less volume over here because pressure was more. The piston was close to particles. Now as we moved the piston up, the particles got more spaces because now they have more volume. So we're going to write that the particles move away from each other and spaces between them increase. Okay, let's move on to the next part, which says that concentrated aqueous calcium bromide is electrolyzed using graphite electrodes to predict the product at each electrode. If concentrated, whenever we have concentrated, so we always form the halogen. Okay, this is bromide is your halogen. When you have concentrated, you don't. Okay, water may you have OH negative and H plus sign. Okay, this is aqueous, so means it has two. But even though you have these ions, but whenever you have concentrated, you're always going to form halogen. So at anode, it's going to be bromine. At cathode, now from water, you have H plus, and from over here, you have calcium. Obviously, H plus will discharge because H plus is less reactive gas. The more reactive, the more above you are in the reactivity C's, the more difficult it is for you to discharge. So it's going to be hydrogen. Okay, molten calcium bromide is electrolyzed using graphite electrodes. Now it's molten. Okay, first it was aqueous. Construct the ionic half equation for the reaction at each electrode when the molten calcium bromide is electrolyzed. At anode, it's going to be bromide ions. You're going to have Br1 negative and it's going to form Br2 gas plus this electron is also come out, so it's going to be 2 electrons. Why 2 electrons? Because we're taking one molecule we are forming, so it's going to be 2 pair. And for calcium, it's going to be calcium 2 plus, and you can add 2 electrons to it to form simple calcium. Okay? Why calcium this time? Because now it's molten. Over here it was aqueous. Okay? Describe a test for bromide ions. Include observations for a positive result. So test is going to be add acidified ठीक है acid add acidified nitric acid. No, you cannot instead of writing nitric acid, just write add acidified silver nitrate. ठीक है, silver nitrate. And for bromide ions you form a cream precipitate. So observation, it's going to be a positive. Test is going to be that cream precipitates of silver bromide form. Okay, calcium reduces zinc ions to zinc. Why calcium reduces zinc ions to zinc? Because calcium is more reactive. Okay, it oxidizes itself, loses electrons and reduces zinc ions. Explain in terms of the movement of electrons how calcium acts as a reducing agent. Reducing agent means that itself it got oxidized. ठीक है. Reducing agent means itself it got oxidized in this equation. ठीक है. So it's gonna be that calcium loses 2 electrons, ठीक है, to form calcium ions. I am gonna tell you how this happened. देखें, over here you had calcium and over here you had Ca2 plus. That means calcium lost its 2 electrons and formed Ca2 plus. Over here you had zinc ions, but over here you simple zinc, meaning zinc gained 2 electrons to form zinc. Okay, state the oxidation number of Z and 2 plus ion. So the oxidation number is this top one, so it's gonna be a 2 plus. Okay, sulfur dibromide. Dibromide means 2 bromine, okay, are produced when sulfur reacts with bromine. Complete figure 4.1 to show the dot and grass molecule of sulfur bromide. Show the देखिए sulfur group 6 में होता है. That means it is only going to form 2 covalent bonds, one over here, one over here. Bromine group 7 में होता है, मतलब only going to form 1 covalent bond. देखिए इसको 8 पूरे करने के लिए it needs to form 2 covalent bonds. In order to get it only needs 1 more. So that is done, and the remaining electrons, again sulfur has used 2 out of the 6, 4 remain, 1 2, and it's going to be 3 4. And for bromine 6 remain, 1 2 3 4 5 6, 1 2 3 4 and 5 6. Okay, we are done with it. Let's move on. Figure 5.1 shows the displayed formula of a compound A. Okay, this is a draw a circle around the functional group on figure 5 that is also present in alkenes. That means a carbon double bond, so that's going to be this bond. If any one of you might be thinking of this functional group, listen up. This is not a alkene functional group, this is a carboxylic acid functional group. Okay, it has a carbon double bonded O and OH, so it cannot be alkene functional group. Let's move on. Reduce the molecular formula of compound. You just got to count each and every atom. So let's first count carbon. Carbon are 1 2 3 4 5 6, so it's going to be C6. Let's count oxygen. It's 2, so it's going to be O2 and H. 1 2 3 4 5. Okay, 1 2 3 4 5 6 7 8 9 and 10. Okay, done. Compound A is a solid at 20 degrees Celsius. Describe the motion arrangement of particles in a solid. So obviously motion is going to be the solid where particles cannot move freely, so they only vibrate about their fixed positions. Okay, they vibrate about their fixed positions, and arrangement is going to be that particles are extremely close to each other. They're regularly arranged, okay, in layers, something like this is the arrangement. So the arrangement is going to be regular. Okay, alkenes react with hydrogen in the presence of a catalyst. Draw a circle on the type of reaction that take place. It's going to be addition reaction. Why? Alkenes may you take C2H4 and you add hydrogen to it. It's gonna form C2H6. Now obviously I've always told you that for an addition reaction, on this side you should have 2 reactants and on this side you should have 1 product to confirm it is an addition reaction. So it exactly has 2 reactants and 1 product being formed. Moreover, look over here, this hydrogen is being added to this ethene. That is why it is forming this. So it's going to be an addition reaction. Name the catalyst used. Remember that for the hydrogenation of alkenes, or the addition of alkenes, we use nickel catalyst, and also learn the temperature. It's 200 degrees Celsius. Okay, figure 5.2 shows the structure of a compound B. Compound B can be polymerized. Draw 2 repeat units of the polymer formed when compound B is polymerized. First, to polymerize compound B, what you need to do is put this carbon double bond carbon in the center, and you need these 2 sides empty. Okay? All this will be shifted downwards, and all this will be shifted upwards and downwards. Okay? I don't want this. So I just take this all my part and I call it my CH3. I take my carbon, put my hydrogen in it, and this all part I put down over here, okay? Instead of here I put it down here, becomes my CH3. It's good chemistry if you always write this C over here, okay? It's gonna be CH3 double bonded C, and a second, what is happening is we have Cl and then we have H, okay? This I put over here, this Cl over here, and this H I put it over here. So now we are done with our standard form. Always remember that in order for an alkene to polymerize, I mean addition polymerization, you first need to convert your monomer to a standard form, and this is the standard form. You need an H. Over here you never had H, you had something like this. This is not an H, okay? This is an H. This is what you call an H. So you need an H. So now we have our our monomer. We simply gonna do 2 repeat units of this monomer. Draw the extension bonds and extend them, and here we go. Okay, figure 5.3 show parts of the structure of a protein. Name the type of monomer used to make proteins. By this time I guess that should be crystal clear. Amino acids make protein. Name the linkage in protein. It's an amide linkage, okay? This linkage right over here, this is an amide linkage. These are amide linkages that are found in proteins, okay? Okay, let's move on. The equation for the Haber process used in the production of ammonia is shown, okay? This is the equation, and the nitrogen for this process comes from there. State the percentage by volume of nitrogen in clean dry air. 78%, oxygen is going to be 21%, carbon dioxide is 0.04%, argon is something more than this, and then you have other gases, okay? State a source of hydrogen for the Haber process. I know it's crystal clear, it's methane. Always remember, okay, I showed you guys in my previous video as well that you get your hydrogen from methane and you get your nitrogen from air, okay? You do fractional distillation of air and get it from air, and hydrogen you get from methane gas, okay? Explain it. The forward reaction in the Haber process is exothermic. Exothermic means release heats that more energy released in bond making than absorbed in bond breaking. Okay, the question is explain in terms of bond making and bond breaking by this reaction is exothermic. Okay, so for a reaction like this, the first step is going to be that you write that bond breaking is okay, that this statement always in terms of bond breaking and bond making questions, this statement always is gonna gain you 1 marks, that bond breaking is endothermic, okay? Always write this statement, bond breaking is endothermic and bond making is exothermic. Okay, the next statement for you should be, because it is an exothermic reaction, so more energy is released in breaking in making bonds than absorbed in breaking bonds. Okay, let's move on. The transfer of thermal energy is a chemical reaction that is called the enthalpy change. Write the symbol for an enthalpy change. Include the sign for an exothermic enthalpy change, delta H, and for exothermic it's going to be negative. Okay, for endothermic it's going to be positive. Aqueous ammonia is an alkali. Okay. Aqueous ammonia reacts with dilute nitric acid to form a salt. That's going to be ammonia nitric acid, ammonium nitrate. That should just come into your mind like randomly, that it should be ammonium nitrate, ammonia nitric acid. So it's going to be ammonium nitrate. Okay, name the experimental technique used to make a solution of this salt from dilute nitric acid and aqueous ammonia. अच्छा देखें, whenever you're taking two soluble reactants, ठीक है, whenever what I say that you take two soluble reactants to make salt, ठीक है, the method you use is called titration, ठीक है. Whenever you take two soluble reactants, you use titration. देखें, over here you're using two soluble reactants. Dilute nitric acid is soluble, aqueous ammonia is soluble. Both are soluble, that is why you're gonna use titration. For example, if you were forming ammonium nitrate by some other method, not ammonium nitrate, it cannot be formed by other method. For example, what you do is that you form some other like zinc oxide and nitric acid, HNO3, and you form zinc nitrate. So that is not going to be titration because this zinc oxide is insoluble. The zinc oxide is insoluble. Between insoluble and soluble, no titration is formed. Titration is done when the both reactant, nitric acid and ammonia, both are soluble. That is why we're going to use the technique is going to be titration. Okay. Here we come with some moles. Dilute ethanoic acid reacts with aqueous calcium hydroxide. ठीक है. We have ethanoic acid, we have calcium hydroxide. Okay. A student reacts 25 cm cube of 0.01 mole per dm cube of aqueous calcium hydroxide with dilute ethanoic acid using thermophthalene as an indicator. ठीक है, that is volume. I know it for sure. The volume concentration of calcium hydroxide, ठीक है, volume of dilute ethanoic acid. Now they'll reacts exactly with these many, ठीक है, moles of aqueous. Calculate the concentration of dilute ethanoic acid. ठीक है, for first concentration, what we need is we need the moles. ठीक है, to calculate the moles first, what can we do? We can calculate the moles of calcium hydroxide. Okay, so for calcium hydroxide, moles is equals to concentration into volume. Concentration is 0.01 into volume is 25 over 1000. Please don't forget this step. You have to got to take the volume in dm cube, whereas in question it's given in cm cube. So it's 0.01 multiplied by 25 over 1000, and that's gonna give you 2.5 into 10 exponent negative 4 moles. 2.5 into 10 exponent negative 4 moles. Okay, now look, these are the moles we calculated from the volume and concentration of calcium hydroxide. So these are the moles of calcium hydroxide. Now if we look at our dear equation, 2 moles of ethanoic acid react with 1 mole of calcium hydroxide. Now we have the moles of calcium hydroxide, so we can form a ratio that 2 moles of ethanoic acid react with 1 mole of calcium hydroxide. So we write that calcium hydroxide moles ratio ethanoic acid moles, CH3COH. So it is 2 for ethanoic and 1 for calcium hydroxide. Now we have the moles for calcium hydroxide, which we calculated out to be 2.4 into 10 exponent negative 3 ratio x. You can find the value of x by multiplying your answer with 2, and that's gonna probably give you 5 into 10 exponent negative 4. ठीक है, these are the moles of ethanoic acid, but we didn't have to find the moles of ethanoic acid, we had to find the concentration. So the formula is moles is equals to C into V. We have the moles for ethanoic acid, 5 into 10 exponent negative 4. We have to find the concentration, and the volume we are given for ethanoic acid is this, 12.5 cm cube. So multiplied by 12.5 divided by 1000. If you solve this equation, you multiply it over here, divide this over here, and you're going to get the value of C. It's going to be 5 into 10 exponent negative 4 multiplied by 1000 first. And then it's gonna be divided by 12.5, and what you're gonna get is 0.04 mole per dm cube of ethanoic acid. State the color thermophthalene in aqueous calcium hydroxide. The color of thermophthalene in aqueous calcium hydroxide is gonna be blue. Thermophthalene is calcium hydroxide is a base, and thermophthalene is gonna be colorless in acids and blue in alkalis or bases. Okay, ethanoic acid is a weak acid. Define the term weak acid in the phrase weak acid. Okay, define the term weak acid in the phrase weak acid. Okay, weak acid is the one that partially ionizes. Okay, what do I mean by partially ionizes? It does not form full ions. Okay, write the formula of the ion present in aqueous solution of acids. All acids, always remember, are gonna contain H plus ions. Okay, let's move on. We have some more moles, I guess. Dilute ethanoic acid reacts with calcium carbonate, with sodium carbonate. Okay, calculate the volume measured at RTP of carbon dioxide produced in cm cube when 3.18 grams of sodium carbonate reacts with excess dilute ethanoic acid. Okay, first we gotta know the moles of sodium carbonate. We have the mass of sodium carbonate. Let's find out the moles. For MR, we're gonna take. Are we given with MR? Okay. For sodium, then it's gonna be there are two sodiums, so 2 times, I know it for sodium it's 23. Go check it out from the periodic table. For 1 times it's gonna be carbon is 16. So 1 times no, not 16, carbon is 12. I'm so sorry for this. Carbon is 12 and oxygen is 16. I was looking at oxygen, so 3 into 16, that is gonna be, let's do it on a calculator. 2 times 23 plus 12 plus 3 times 16, and that is going to give you 106. Okay, so what we do is we take our mass, which is 3.18 grams, and divide it by 106, which is the MR. Mass over MR gives you moles, so it is going to be 3.18 divided by 106, and that is going to give you 0.03 moles of what thing? Of sodium carbonate. 0.03 moles. Okay, now we form the mole ratio. We know what do we have to calculate is the volume of carbon dioxide. Now we go to our equation. Equation is very important. We know 1 mole of this forms 1 mole of carbon dioxide gas. So no, not carbon dioxide. 1 mole of sodium carbonate is going to form 1 mole of carbon dioxide gas. So these many moles, these are the moles of sodium carbonate. So these many moles are going to form the same amount of moles for sodium carbonate. Okay, the molar ratio for Na2CO3 ratio CO2 gas is going to be 1:1. So if you have 0.03 moles of this, we're going to have 0.03 moles of carbon dioxide. Now the moles of carbon dioxide, is it easy to find the volume? The simplest formula is going to be mole equal to volume over 24,000 cm cube. Why I'm taking 24,000? Because they asked me for the volume in cm cube. If they asked me the volume in dm cube, I would only have taken 24, but now it's in cm cube, so I've taken 24,000. Okay, so the volume, now I'm just going to plug in my values. I don't have my volume, and the moles I know are 0.03, so I multiply my 0.03 with 24,000, and that is going to give me 720 cm cube. Okay, now sulfur dioxide contributes to acid rain. State one source of sulfur dioxide in the air. Burning fossil fuels containing sulfur. That is easy. Describe one method of reducing the amount of sulfur dioxide getting into air using low sulfur fuels. Or it can be flue gas desulfurization. Just consult the syllabus for this. In the Conrad process, sulfur dioxide reacts with oxygen. Complete the simple equation for the reaction. Sulfur dioxide plus oxygen is going to form sulfur trioxide, and that's a 1 mark equation. And is it balanced? How many oxygens do we have? It's going to be a 2 over here, and I guess it's balanced. Let's move on. Okay, ethanoic acid is manufactured from methanol. Okay, ethanoic acid is manufactured from methanol. We take methanol, we add carbon monoxide to it, and we make ethanoic acid. Predict and explain the effect, if any, on the position of the equilibrium when the pressure is decreased and the temperature remains constant. Pressure is decreased. Okay, we check out the gaseous moles. We have, okay, this is 1 mole, this is 1 mole, this is 1 mole. So in total on this side of the equation we have 2 moles of gases, and on this side we have 1 mole of gas. So when we decrease temperature or decrease the pressure, it affects the side with more moles. So this side has more moles. Equilibrium will move shift towards left. Okay, we're gonna write that equilibrium shifts towards left, or the reactant side as it has 2 moles of gaseous reactants whereas right side has only 1 mole. Okay, because pressure is only going to affect your gases. All these 3 are gases. Okay, you cannot count the moles of solids and liquids into it. It's only for gases. Okay, predict and explain the effect, if any, on the position of the equilibrium when the temperature is decreased and the pressure remains constant. Acha, first the temperature was constant and now the pressure is constant. Okay, now we got to check if the reaction is endothermic. Acha, I'm gonna tell you one thing that is super important, and that's gonna be that, look, they've told you the forward reaction is exothermic. You just draw a reaction to a forward arrow and write exothermic. And when they told you the forward reaction is exothermic, always know that the backward is gonna be endo. Okay, and position of equilibrium when the temperature is decreased, and when you decrease temperature it moves towards the exo side. You should know that when you decrease temperature it moves towards the exo side, and when you increase temperature the equilibrium will move towards the endo side. So right now you're decreasing temperature, so it's gonna move towards the, it moves forward towards product side or left side, or right side, sorry, product side or right side. Okay, ethanoic acid can be produced by bacterial oxidation. Okay, describe one other method of making ethanoic acid by oxidizing an alcohol other than methanol. Okay, you can make ethanoic acid. You have to make ethanoic acid and name of the alcohol and oxidizing agent. Okay, over here you oxidized methanol. You can oxidize ethanol as well. Okay, an oxidizing agent you can use potassium manganate. Okay, KMNO4. So that can be oxidizing agent. You should know that this is a very strong oxidizing agent in a syllabus. And ethanol, when oxidized, forms ethanoic acid. And you might be thinking, then how methanol formed? Okay, methanol formed ethanoic acid because 1 carbon was added to it from carbon monoxide. That is how. But over here we have KMNO4 as the oxidizing agent, so it cannot add carbon to it, so it is going to remain ethanoic acid. Okay, ethanoic acid reacts with propan-1-ol to produce an ester. Name the ester and draw its displayed formula. Okay, ethanoic acid plus propanol, so it's going to be propyl, not E, not an E and propyl, it's going to be propyl ethanoate. How do I know it's propyl ethanoate? Because you write the name of the alcohol first, that is propanol, and after that you write the name of the acid, which is ethanoic acid. And the displayed formula is, first I'm going to draw ethanoic acid, bond 2. Now this is my ester linkage. This is my ester linkage, C double bond O पे दो. And after that I'm going to draw my propyl alcohol, which is going to be 3 carbons. Done with the job. 2 carbons I drew for ethanoic acid and 3 for my propyl only propyl alcohol. Okay, Let's move on to the next question. Table 9.1 shows the melting points and relative electrical conductivities of three elements using ideas about the structure and wanting to explain the differences in melting points of magnesium and phosphorus. ठीक है. देखिए, magnesium has high, phosphorus has low. Why? Because देखिए, magnesium is a metal, ठीक है, with strong metallic bonds which are electrostatic forces of attraction between the positive ions and sea of electrons ठीक है, whereas phosphorus is simple molecular structure with weak intermolecular forces of attraction between the molecules. अच्छा देखें, अब magnesium is a metal, so for metals we know that it is going to have a lattice like this, and in the lattice what is going to happen is that you're going to have positive ions like this, and you're going to have electrons. This is a metallic lattice, and there's strong electrostatic force of attraction between the positive ions and the negative electrons, giving it high melting and boiling point, whereas phosphorus is going to exist as molecules. These are phosphorus molecules, and between these two molecules is going to be weak intermolecular force of attraction, hence giving phosphorus a low melting and boiling point. Okay, the difference in electrical conductivities of graphite and phosphorus. देखें, I know that graphite is going to conduct and phosphorus is not going to conduct. Why? Because देखें, in graphite each carbon bonded to three other carbon atoms, to three other carbon atoms, so fourth unbonded delocalized electron can move through layers of graphite to conduct electricity. ठीक है, layers of graphite to conduct electricity. ठीक है, in phosphorus no free mobile electrons, ठीक है, to conduct electricity. Diamond and graphite are different forms of carbon. Explain in terms of structure and bonding why diamond is used in cutting tools. देखें, in diamond okay, so it's going to be in diamond each carbon atom bonded to four other carbon atoms by strong covalent bonds. As diamond is a giant covalent structure, okay, now we have to calculate the empirical formula, and that's going to be the last question of our paper. Okay, to calculate the empirical formula, first we have to calculate the moles. ठीक है, we write the percentage composition of every substance. Okay, for carbon compound we have phosphorus ratio oxygen ratio chlorine. Okay, contains 20.2% phosphorus, 10.4% oxygen and 69.4% chlorine. Oh my god, that's gonna be C. Acha, ठीक है. Now we divide them by their MR to get the moles. For phosphorus it's going to be 32, for oxygen it's going to be 16, for chlorine it's going to be 35.5. How do I know this? I know it because I've learned it from the periodic table. ठीक है, just divide it and you're going to get the values. ठीक है, 20.2 divided by 32 is going to give you 0.63 moles. Okay, next is 10.4 divided by 16 and that's gonna give you 0.65 moles. And the next one is this 64? Yeah, no, it's 69. Next one is 69.4 divided by 35.5 and that's gonna give you ratio 1.955 moles. Okay, you divide all three by the smallest ratio. The smallest ratio is 0.63. Okay, among these three moles, the smallest moles is 0.63, so it's going to be 0.63, 0.63, 0.63. That's going to be 1 ratio almost near 1. This is going to be, if you divide 0.65 by 0.63, you're gonna get 1.03. that is, round off it to 1, then you get 1.955 divided by 0.63 and that is gonna give you 3.1 and you round it up to 3, so it is gonna be P1O1Cl2. You don't write the ones below, so you cut them down. It's gonna be POCl2. I hope that's correct. Compound phosphorus, ठीक है, phosphorus I've taken correct, oxygen I've taken correct, and chlorine as well I've taken correct. I hope that's correct. And with that we come to an end of our paper. I hope you liked my video. If you did, do subscribe to my channel and consider liking it. It would mean a lot. Thanks for watching. Bye bye.